Hi, Johannes. Welcome back.
Thanks for having me again.
Yeah, and you didn't listen to your own podcast, I heard.
Yes, the problem was that I didn't recognize it was already online. I looked today just curious before recording this and saw it and saw that you already published it. So yeah, I'll be listening to it. Um,
Very good. So I thought that your mostly nerdless blog is down because of the traffic redirected by the podcast, but nothing happened, unfortunately.
no, I didn't get that much traffic. I hope it changes with this podcast, but no. But it's
Yeah,
interesting to tell people my story, and I'll
yeah.
tweet it
So,
soon.
so eBPF,
Yes.
you are interested in it. What it stands for?
So
eBPF.
eBPF. I'm not the greatest expert in it, but eBPF stands for Extended Berkeley Package Filter. As far as I know the history, it's like in the 90s, people started to develop firewalls and package filters. And what they want to do, they wanted to allow users to write their rules in like a language, because you don't want to have like hard coded rules in your package filter, and the package filter is implemented in the kernel. So they started out to write BPF programs. These are like small programs, typically written in C, and you could use them to, for example, drop packages, or essentially to drop packages that you don't like, to create simple basic firewalls. And then in around 2017, people started using it for more stuff, especially like Brendan Ike, who also invented Flamegraphs, like gave talks about it, wrote blog posts about it on how to use BPF also for monitoring, and then BPF gained many more features, and then it changed its name kind of to Extended Berkeley Package Filter, because it now can do much
Oh,
more than just package filtering. So I just today talked with someone from Grafana, and they use eBPF in their monitoring products. The same with like people from Datadog. So they essentially use it for monitoring purposes, because the nice thing about eBPF is that you can essentially attach to hooks in the kernel small programs, and these programs can, for example, attach to hooks related to network. So you can drop packages as before, and you can essentially use it to gather information. For example, small in a small sample program, you can attach to the exec VE hook. So every time someone on your system calls exec VE, a small program is executed in the kernel, and you can use this, for example, to count how many times a user executed a new program, and that's pretty nice.
mhm. How many interesting system hooks are there on Linux? Or
Well,
what are
take
the
them
most
into account.
interesting, the most interesting hooks? So, is this everything exposed as a hook on Linux, or
Every system call, as far as I know. And the cool thing is, with new kernels, you're even able to write new schedulers, so new process scheduling directly in eBPF. So you can write your own schedulers, which is pretty crazy. If you ask me, like writing a scheduler and be like, "Oh, I just installed this new scheduler on my system. I wrote it myself," would be a pretty cool project to work on. And there are probably people in the enterprise world working with these features to get the best out of the system. So that's pretty neat. And also, of course, like monitoring. I'm a monitoring guy, so you can monitor, for example, file accesses and more, and then store it by. Of course, you have to be a root user to use it. That's the main difficulty, but you shouldn't like be running programs that can access all user memory. As a non-root user, this would be pretty terrible.
okay? So, what it is a small piece of bytecode which runs on Linux kernel, which
Yes.
can be easily installed, and it intercepts intercepts syscalls, or
Not
is
really intercept. It's like attached. You attach it to hooks. So interception means like it in between, but it's rather called with the it's rather called when a syscall is called, and there's hooks that have more functionality. For example, their network package receive hooks where you can say, "Oh, please drop this specific package." And this feature, and also because you can use this feature to forward packages, is used by Facebook to implement their load balancer directly in kernel. And I think they saved like a lot of performance there, especially because you don't have to cross the kernel to user land boundary. Because the main problem with like a load balancer is that when you call always like directly into the kernel and be like, "Oh, give me send this package to there," and so, and when you do this in kernel, you don't have to cross the boundary that much. So that it's essentially a good way to improve the performance of such things.
Mhm. But you say so it is called in parallel. So let's say I would like to save a file, and I installed such a hook. So then the syscall to a file and my eBPF, how to call it, extension is going to be called, right?
Yes, and I think it's like hook dependent. What features like the hook has, for example, as I said with network, your hook can return a value that tells the kernel like drop this package or not. And there are other syscalls for execve where you can't do much about it.
Mhm. And
As far as I understand it.
what happens if you block your extension for 10 seconds?
That's not possible. So the cool thing about running this in the kernel is that you have a verifier. So how it works, you compile your C code typically down to a bytecode, and this bytecode is then executed in the kernel. And the kernel even has like a runtime. It has a small VM in it, and it even has like a JIT on modern systems. So a just-in-time compiler in your kernel, which is pretty cool. Um, but so it has a verifier that, for example, guarantees that your program terminates. So you can't have like unbounded loops. You can't have unbounded recursion, and it's quite limited on the complexity of your programs. But that's on purpose because you don't want to block your kernel like for 10 seconds, because this is pretty hard to debug them. So usually these programs run pretty fast, because yes, as I said, they are restricted to terminate, and usually termination is a pretty hard problem in computer science. So for the computer science nerds out there, it's the theorem of Rice, which states that it's impossible to prove the termination of a program. Was it another film? I don't know. But it's essentially, it tells you that with Turing complete languages, it's impossible to essentially prove that the program, statically prove that the program is terminating. But with these programs, it's possible because the verifier restricts your program to be of the kind that it terminates. And if the verifier can't tell you that it terminates, then it just says, "Good, I'm throwing an error. Please rewrite your program again." And that happens when you write larger programs, as I heard from people that wanted to use larger loops.
I forgot actually my theorem, not my theorem, a theorem which I forgot the name. This was with asynchronous communication is very similar. So if you have asynchronous communication with external systems and you send messages, it is impossible to distinguish whether the other system is late or is just no more available. And this is a 3-letter theorem. So I think there were 3 people involved in it, but sounds very similar to your theorem. So I would have to look it up. Mm-hmm.
Yeah, and that's essentially it. So it helps you. So the eBPF programs that I saw around. So I'm only in the eBPF world now for like 1-2 months. They're usually quite small, especially because you have these restrictions. But still, these programs are small, but they are powerful because they can access a lot of helper methods. So they are hundreds of helper methods with which you can access a myriad of information, and that's pretty cool.
Okay, my theorem, the name I found it. This is FLP and stands for Fisher, Lynch, and Patterson theorem. And this is you can do agreement in asynchronous message passing if even one crash failure is allowed. So and this is important for me for my work in distributed systems, because in client systems or in enterprise software, if you would like to have an application server which communicates with other application servers, it's easy to explain that it's actually impossible to have a consistent communication. So we have to do something like a business and with a business logic. And without the theorem, there was endless discussion, because developers wanted to still do it. And with the theorem, for me, is a shortcut. Say, look, there's a theorem. It is impossible, so we should do something about it, right? So this is why I immediately remember my theorem. What was your name of yours? You remember?
I can
You
look it up.
you said no problem. You said a name, but I couldn't.
I thought it was. Oh no, it's the theorem of Rice only tells you that from Gordon Rice only tells you that it's the extension which tells you that you can't obtain arbitrary properties of programs statically, but I think it's based on another theorem. Oh yeah,
No
of
problem.
course, it's based on the halting problem. So it's essentially the halting problem.
Halting problem. Okay,
Yeah.
because it's very similar. So this is why I said
Yes.
maybe this is okay. Interesting. Okay, so so what it means is actually that the kernel, Linux kernel architecture is similar to Java's architecture, right? So we have a bytecode verifier, we have bytecode, we have small programs, and yeah, the verifier doesn't verify the for endless loops. It doesn't eliminate them, but more for security. But interesting, right?
Mhm. And if you go one level deeper, and that's the thing that probably not that many people know, is that when you're writing assembly code, that's not the code that your CPU is really executing. So what your CPU usually does, especially with your x86 CPUs, is that your CPU translates these larger assembler instructions down to smaller instructions. So it essentially has a just-in-time compiler for your assembly code, which
Hmm.
then runs on a complex VM implemented in silicon. But that's pretty cool. And with some CPUs, I think you can even update like the microcode. And so uh, when you're
Hmm.
running code on your JVM, it's essentially you have a JVM running on a VM executing assembly instructions, then in a VM embedded in silicon, which is pretty cool.
Yeah, indeed. So eBPF. So we can install the thing, and yeah, let's forget Java. So I have my terminal. How to install an eBPF extension? Do I need a specific tool, or can I use just the standard shell, or how it is working?
So usually you don't run your BPF alone because that doesn't make any sense. You
What means
usually run
alone?
it. You yes, you can install it. There's a system call with which you can a system call called BPF, and you can pass it. As far as I know, you can pass it like your program, the bytecode of your program, and then it's installed. And you told like, hey, that's please attach it to a hook with another system call, and that's fine. You can attach it, and it's fine. But when you want to do it on your command line, you usually use a program like BPF tool with which you can load these programs. But more commonly, what like the monitoring people do, they use a userland program that does this for them. So they have a userland library. It's typically like implemented currently like in Rust, Go, or Python, and this allows you to easily compile these programs and then load it into the kernel and get also information to and from. So usually a monitoring application would like to get the information out of the kernel that it collects in the kernel, and therefore it uses eBPF maps. And the idea is that you have a special kind of map. Maps are more like a collection data structure of fixed size, not to be confused with the Java maps, which are like
Hmm.
just hash maps, but the eBPF maps could be an event buffer, it could be a queue, it could be an area, and it could be a dictionary. And so this is used to communicate, and that's pretty cool. And then you usually have like your program written in Go, Rust, Python, or so, and you define your eBPF program in it, and then it takes care of attaching the hooks and everything using the system calls. Because when you're doing monitoring work, you don't usually want to fuzz around with the system calls. That's where libraries come in. And then essentially, when you have such a library, you can just run your application uh, as a root user, and you do have to have some capabilities that usually you have as a root user, and then can run it, and it works.
So it doesn't have to be. I mean, what you have to compile. I think C usually, right?
Yes.
This is the standard C to the bytecode. It's called
Yes.
bytecode, and then the bytecode has to be copied somewhere. I guess it has to be in path of.
It has to be loaded. I think it has to be loaded via system call, so you can load these programs.
Okay, so you have
into
to
the
call
program.
a command which loads the bytecode to the kernel, and then you have to
Essentially.
configure the kernel somehow that the kernel knows there's a bytecode as well, right?
Yeah, but that's where the system calls come in. So you
Okay,
have
so there are
system calls
meta
that
system deployment calls which deploy the bytecode, right?
yes.
And how to call the meta bytecode? So I'm just interested, So how from the terminal or whatever, is it possible to initiate the installation with the system calls, or in order to execute system calls you need a C program? You know what I mean?
Yeah, but the system calls like execv are or file system calls, they you have a normal C program, you have a normal program that executes the system calls. So system calls are always used by all programs to interface with the kernel. So that's no problem.
But it could be also used by shell, right? No, shell
Of
could
course,
also.
yes, of course. Your shell does execute
Yeah,
system
exactly.
calls, especially the exec family of system calls. Every time you want to start a new program, for example, when you type ls, it
Exactly.
starts a new program, usually the ls program, and this ls program uses file system calls. And there's even a cool idea that someone told me that you could use eBPF to improve the speed of to improve the speed of small file searches, because you could like search for file in eBPF. I know like limited the amount of files that you could look into is limited, but as it runs in eBPF, you don't have to cross the system, the kernel to user land memory that much. So you could do quite some fancy stuff. But that's only what I heard from people. There are many people in the monitoring world pretty excited about eBPF. There will be, I think, 2 talks at FOSDEM on eBPF. So if you're more interested in eBPF, come to FOSDEM. It's a great conference.
Yeah, why I should go to FOSDEM if I have you and I can ask you right now, right? So this is this is just it's just greener, to stay at home and ask you than travel to FOSDEM
Of
and
course.
become sick at the end of the conference, which is
Mm-hmm.
usual. So, but back, what would I actually ask? Is there a generic terminal command where I can execute, a syscall of my choice? You know what I mean? So there should be something, where you say like a command, a meta command, because this is what I'm interested in. This should be available. I mean, why not, right? Why I should write a C program first to initiate a syscall? Why there is no command facade, or how to call it, which allows me to execute whatever syscalls I like. I mean, this should be possible even for debugging purposes.
There is apparently this there are apparently some GitHub projects that allow you to do this.
Okay, because I was really curious. Like, this is strange that you cannot just use it directly, especially not on Linux. So on Mac or Windows, I would understand, but on Linux, I mean, yeah. But okay, this is covered.
Oh, there's. Oh, yes. When you are on obscure systems like AIX and Plan 9, they have a system call command. And there's a syscall, and there's a syscall project on GitHub that allows you to do the same.
Yeah,
So
and to do the syscall calls, you have to be root because you're calling the
no, no, no,
syscall.
no, 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 no. For syscalls, you don't have to be root. Just for eBPF to install eBPF programs, because eBPF can access so much. No, syscalls are used by every program. Just like printing something
No, I mean the
on the
meta
file.
syscall to install.
Oh, and the to run this the meter syscall to install
Yeah.
eBPF programs. Yes, you have to be root, of course. It would be terrible if people could just like in their
No, no, no. But
uh,
what's I'm interested right now? So obviously, because there are syscalls which can be executed by anyone, and syscall which can be executed by root. So it means either there is a similar permission model for syscalls,
yes.
or there is kind of interceptor decorator or something which says, okay, my syscall can be only executed by someone and the other one by everyone, right?
But I think that's equivalent. So there should be. I think there's the capability model in the Linux kernel, where you can like give users some capabilities. But if I'm honest, that's where my knowledge of Linux ends. But you can probably Google it and find it anyway.
No, it was just because syscalls I had you. So okay, now let's. I'm really interested in the stuff, so it's interesting. So, and what you did now? So,
So so what I did was that in last year in June or so, I met someone at the Karlsruhe Entwicklertage, where I was also a speaker, and I met someone from Elasticsearch, and we talked about it, and we're like, hey, that I wanted to know where monitoring, where the monitoring field goes, and the person told me, hey, you should look into eBPF. And then I was on conferences a lot. I did like my 6 conferences in autumn. Was also on holiday, and then I didn't have time to look into eBPF. But then when I looked into eBPF in
you were at 6 conferences. You had no time to do some eBPF.
yeah,
Conferences are this as you spend the entire time, in train. Then you talk for 1
yes.
hour, and then you can hack in train eBPF again, right?
Yes, because no, I wanted to do work at SAP too for Submachine, but essentially I met at the JFL conference, which is a pretty nice conference in November in the Netherlands, which I can really recommend. It's cheap, but it's a 1-day conference with many cool speakers. And there I met Mohamed Abu Laid. He gave the talk on eBPF at Davos and also at JFL. So we crossed paths, and I talked with him about my ideas, and now he kind of helps me a bit as my eBPF advice in this project, because I thought like, okay, I want to learn eBPF, and there's a new book by Liz Rice out called Learning eBPF, published in October and available as a free PDF too. It's from ESO Ireland. And the cool thing is there, I thought like, hey, I could just read this book and be like, yay, I know a bit of eBPF. But then I thought, no, that would be quite boring, because I'm not contributing to the community, and I want to contribute to the communities that I want to be part of. So I thought, is there a project that I could contribute that really improves the community? And one of these projects is giving the community a eBPF API in Java, because there are libraries in userland for working with eBPF in Python, in Lua, in C++, in Go, and in Rust, but there isn't any library in the JVM world. And I disliked this, and so I started the Hello eBPF program, the Hello eBPF project. You can find it on GitHub, and I'm also blogging regularly on this. And the first blog appeared on the 1st of January. The first blog post where I tell people like the concept of this approach. And so the main concept is that with Project Panama, it's quite easy to interface from Java into C. And
So
so
what you did? So the blog post is mostly nerdless.
yes,
.de,
it's there.
mostly Netless.de, and the name is Hello BPF, developing eBPF apps in Java. It was
Yes.
not January. You are completely wrong. It was December 31st. Sylvester.
I tweeted on January 1st, and they usually use the date of the tweet.
Yeah, no one cares about Twitter anymore. So, but the truth is on your blog, December 31st, And now you said something. I wanted to interrupt you for another
Oh
reason. So
no,
you're
yeah.
using Project Panama, which is like GNI next, and you can call from Java native code without playing or using C and header files. So it's like the
Yes.
modern way for GNI. What was your experience with it? So how it starts? So because what I understand, there is a kernel is written in C with some APIs, and you would wanted to access it from Java, and you decided to use the Project Panama. This is the new GenI. So you started with Hello World, I guess, right? So you wrote a small program.
So the main idea here is that there are already like userland libraries written in C++, and one of them is the BCC library, and they have an interface in Python. That's just the BCC, just the official BCC API, and BCC was like first. It was like the first proper userland library, and it's now
And
you
what is
see that.
BCC? The bytecode, or what is BCC?
And so BCC is a project that allows you to easily develop eBPF programs and easily interface with the kernel. Like it abstracts away many of the pain points, and it's like the first project that did this. And nowadays people use libBPF, but this was BCC is like one of the most commonly used libraries, and there is a Python API for this, and it uses the Python foreign function interface. And before JNI, it was quite hard to do foreign function interfacing in Java, because before you had to like develop your JNI code, and it's messy and you have to compile it and everything. And nowadays you don't have to compile anything to do for to have a to interface with foreign functions, to interface with the C functions of the libbcc. So what I did, I used Panama to write the wrapper like BCC did with the Panama API, with the Python API. I wrote a wrapper across
You used the
around the
JExtract, I think,
libbcc.
right?
I use JExtract, yeah, and JExtract is a pretty neat tool.
So how you
The
use it? You pointed JExtract to what?
I point the JExtract to a header file, and in this header file, I just included all the header files that I wanted to use. For example, the relevant Linux headers, the relevant stdlib headers, and the relevant libbcc headers. And then JExtract generates me thousands and thousands and thousands of lines of code that essentially define the 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 native functions, C functions in Java. Kind of they define like the structure of how different structs in the header files look like, how the functions are defined, and that's pretty cool because then you can use all your neat little C functions that, for example, libbcc gives us. Use them directly in Java, and it's far less of a mess than JNI. So it's currently in preview, but it will be stable in JDK 22, and I'm looking forward to it because it's like one of the biggest changes in the last years.
Yes, especially it becomes more and more important, right? You use it for eBPF. I had to use it for encryption once, or you can use it, for to access, some, AI programs compiled from different languages. It becomes increasingly important to be able to nicely, invoke foreign foreign languages, foreign executables. Okay, so what's not clear to me, which headers you picked. Your first goal was to have and kind of, how to call it, development environment in Java, right? So this was your first goal, to be able to create eBPF project. We are not talking about installing the eBPF thing. You wanted to create eBPFs in Java, right?
So kind of both. So the main idea is you have these userland libraries that make it easy to develop eBPF based applications. So these applications usually consist of your eBPF code, so the code that's then loaded in the kernel. They consist of code that allows you to load this into kernel and to work with it, to work also with eBPF maps to get information to and from the eBPF programs. And this code around is usually written in another language. For my Hello eBPF program, the code is written in Java, so you write a Java application around your eBPF program in userland that allows you to work with the eBPF program to get information to and from, and that's pretty cool. And I used libBCC as the groundwork because I essentially copied the Python API to BCC, made it into Java, and implemented all the nice helper functions that the Python API gives us. So it's essentially a clone of the Python API in Java. And the Python API uses CFFI, and I use Panama. And so it's quite easy to transform Python code into Java code
Yeah,
now.
this is what people don't know, or it is not obvious that Python usually doesn't do much, right? So Python does, it calls C usually all the time,
Yes.
right? And if Python would do more, it would be incredibly slow. So Python,
Yes.
calls usually as fast as possible something external. And now with Panama, we can absolutely do it with Java. So what you demonstrated is actually how we can migrate, Python programs to Java, which is even more important than eBPF because now we could extend on it, and run the business logic in Java, which will execute orders of magnitudes faster than Python. Yeah, it is. No kidding. It is 30 times faster roughly. So it is orders of magnitude. So yeah.
I looked into the Python VM because I started, I don't know, I like to do more Python stuff on the side just as a hobby, and so I looked into how to create a Python debugger, and I'll be with this talk in the PyCon Lithuania at the beginning of April, talking about how to create a Python debugger, and you can find it also on my blog post, but on my blog, but what I saw is that yes, Python is quite slow, but it doesn't matter as you said, because we're just calling into C. And the cool thing is that with modern technology, in my case GitHub Copilot, it's fairly easy to semi-automatically convert from Python code that uses FFI to Java code that uses Panama. And so in the future it will be pretty easy. And when I write this code, mostly I just take the Python code that uses FFI, paste it directly into my Java code as a command, and then tell GitHub, and then GitHub Copilot transforms it into Java code, and that works better than I expected. It still produces some interesting and hard to fix bugs, but still, this is why I can proceed so fast, because the combination of Panama and new machine learning techniques makes it pretty easy to do these transformations. And yeah, maybe I'll write in the future blog post or give a conference talk about
Yeah, I suspect
transforming
both, right? So I
this.
suspect
Of course.
more and more conferences. In one point of time, you forget about Java, right? So you will then you will be in the meta circle where you will talk more, know how to talk nicely and look pretty on stage, right? And not how kernel is working. So you have to be careful.
Last year I only did like 14 conferences and 40 blog posts, so I think that's enough. This year I'm going to 5 conferences till mid of mid of April. So you see me, for example, at Javaland in April,
Very good.
talking about debugger internals. If you want to have a deep dive, come to Javaland or come to Confu in Canada. Where I'll also be talking about debugging.
Or so this is a quite long travel, from Javaland to Canada, but
Canada is in February, so I'll be going to Montreal in February, 2 weeks after going to FOSDEM. And then after that, I'm going to the Vox Days in Zurich, where I'll be talking about Java bytecode instrumentation and how to use it for profit. And then I'll be in Lithuania and in Vilnius for the PyCon there, and then I'll be at Javaland. That's like my plan for this year till
cool.
April.
What do you talk about? I forgot now. I'm thinking about your conferences right now. So the Panama thing. So what's also interesting, Java is pretty lean and very productive. Meanwhile, so with Java 21. So and the other day, what happened is someone commented on a screencast is why I'm flagging JavaScript with Java, and it turned out because I used var, he thought that this is JavaScript. and it was Olin. This is actually the best comment ever. So I tweeted about that because I see what. It's like this is okay. This is Java 21. Sorry, it's not JavaScript, right? So what means is if we provide more and more Panama APIs, how to call it? Yeah, native APIs written with Panama to external interesting things, then the Java developers, modern Java developers, which just write efficient Java code, can be as efficient as with Python. So this is what's interesting. So this is a huge opportunity for Java, to use the boring but proven C libraries. I remember back then, and I don't know whether it's still alive. The NAC library in C. It's just like numerical mathematical library I had to use once or whatever. So there are lots of libraries you have to use, and Python is great with it. But with Panama, I think Java is as good. What you describe, it doesn't sound bad, right?
So it still is slightly harder to use than the FFI in Python, but only
Why? Why
slightly.
that? What's the main? What is the main difference? This interests me.
Type safety. So with Python, Python can do lots of magic that you can't do in Java, because Java is safer. It has like proper type safety, and
Yeah,
there are some things you can't do in Java that you can't do in Python, but it's fairly easy to work around. And especially with the JExtract tool that we have, it's pretty easy to take just your header files, pass them to JExtract, and
yeah. Hmm.
JExtract generates you Java code with which you can access these things. And I know I wrote with John Vernet, who is one of the developers that works on JExtract. They currently working full steam ahead on making JExtract as best as possible. Currently, the performance isn't as great as with JNI, so that's a problem. But I think there are pretty smart people working on making Panama as fast as JNI, and later even faster, because with Panama we can do some improvements that weren't possible before.
Yeah, but okay. So with that, so you have the same functionality what Python has. I still not know exactly what Python has. So what Python has is you can register syscalls via the Meta API as root, right? So you can.
No, Panama has nothing to do with Cisco.
No.
So, oh,
This is
you mean
we close
MVCC
Panama. This is
API?
these.
Yes. Okay,
Yeah,
good.
we back to
So,
Python. So the Python project
yes.
for eBPF development. What can it do? It just registers with the meta syscalls eBPF extensions, right? This is possible.
And more. So essentially, what you can do, you have a nice little API with which you can compile eBPF programs. So you just pass this BPF class, your eBPF program written in C, and it does
Ah,
all the compilation for you. It does all the loading for you. It does many things. It does all the wrapping your eBPF maps, so you can access them easily as if they were proper Python dictionaries, for example. So it's pretty easy to use. And that's essentially what I want to replicate in my Hello
okay.
eBPF
So
project.
the Python thing is similar to GCC, or I mean to
It
the.
uses it under the hood. It uses LVM under the hood to
No.
compile.
What I meant for me as developer, if I don't care what happens behind the scenes, I have a C code. I run the Python thing, and I get, in best case, an eBPF extension compiled and registered in the kernel.
Essentially, yes. So if you run your BPF Python program, it registers it automatically, and you can use it. For example, you create this by your BPF class. You can just tell, here is my BPF code, and then you can tell, hey, please register it to the syscall, and it does it for you, and you don't have to care about compilation and everything. The main problem here, and that's why people lightly started to not use BCC that much in new projects, the problem is that you compile it always. So every time you run your program, you're compiling your eBPF program, which is not that great, because you have to ship your LVM to every system where you want to run these programs. And therefore, with BPF, it's possible to pre-compile this to bytecode and just store the bytecode into your application and then load it via libBPF. And that's also an aim for Hello eBPF for my project, that later you can get a job with where I compiled in essentially the eBPF code to bytecode, and then you can load it, so you don't need LVM
So the
always.
the 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 Python, what's the BCC is the name of the library,
Mhm.
right? The So what BCC does, it does everything at once. So
Yes.
and libbpf, it just does the second thing. So it just
Yes.
deals with the pre-compiled bytecode, right?
It just deals with the pre. As far as I understand it, it helps you to just deal to pre-compile bytecode, and then I do it at build of my application. I just pre-compile the bytecode, and then later I only use this bytecode. And when I run my application, I'm just loading this bytecode, and it's a little bit harder than this because the problem is the Linux kernel tends to change. Also, the eBPF APIs tend to change, but nowadays, what's possible with the Core approach, I think it's called, um, libbpf allows you to compile it once, run it everywhere. So you compile it down to something like, when with shared libraries, you then have a linker, you have a dynamic linker that essentially links your application. It knows, oh, this function lays at this location in my current heap. That's the same what it does. So it modifies at runtime then your application to your current Linux kernel. So it works, and that's pretty neat because you can compile it once on your kernel, and it runs on all other kernels too.
Yeah, this is for Java developer less exciting, but nice feature, I would say, right?
Of course, it's for the Java developers. Like, we have it since like the beginning, but it's really important for eBPF, and that's also a thing that I want to do in the future. So in the future, I want to have a Maven task with which you essentially a preprocessor that runs in
Hey,
your
Johannes,
Maven
this is
task.
available before you were born. Can we say that?
Java or
Yeah,
what? I don't
1995.
know. No, I'm older than this.
Oh, okay. I thought you're younger. Okay, so you
No,
see,
no.
so eBPF keeps you young.
But the
or
thing
s-
is, yes,
or the submarines, or
all the
submachines,
submarines, yes, the
submarine.
submachine,
Okay, cool. Another thing. So libbpf installs the bytecode to the kernel. So
essentially.
is there a command internal which just produces the bytecode, or do I have to use the lib ebp the no sorry the BCC
I think you can compile it via
LLVM or
BCC. It
something,
should
right?
it should be possible to BCC to compile C
Because I don't
compiling.
get it why we need the BCC at all. Because you could just use one command to produce the bytecode and then use libbpf to install it, and I'm done, right?
Of course, that yeah, and the main advantage is with libpc that it makes it easier to prototype applications. So it's just simplicity. So it does a tool that does everything for you, and you have a nice API, and that's fine. And it makes it just easier. And the thing is, it was there first, and because it was there first, there are far more tutorials, especially older
Okay.
ones. There are far more books covering this. With the Learning eBPF, um, a book by Les Rice. There's also chapters on using libbpf, as far as I saw. So it's just libbpc is simpler to use in the beginning. It's harder to use later because
Yeah,
it does more
because my
magic.
thinking is if you deal with eBPF, you are so low level, so it doesn't matter anymore whether I compile it by myself or by library, right? I mean, I'm on the kernel. Is it not like is it I
It's
mean,
deep down, yes, it's deep down, but the main problem here is that it's when you have a nice, simple to use Python API, it makes it easier to get
okay,
started. And
okay,
so it's far easier to get a Hello World program running. But with my Hello eBPF program, I want to make it as easy as with the Python BC API to use libbpf. So I'm working
okay.
on it. It's something that I want to do in the future so that people can just use libbpf, be fine, compile it once, run it everywhere. But that's still bit more effort because the libbcc offers some kind of front end, offers many helper functions that I would have to re-implement essentially in Java. but that's some work. But if there are people out there who want to join me, just come to the whole eBPF GitHub project and make progress, make issues, take part in discussions. So it's a project that I want to like create with the community. It's a side project that I do also like as a hobby. So please come, take part of the discussions, and make it better.
Yeah, because the hard work is done, right? So I assume if you can call one function, you can call the other as well. So now you only have to replicate a bit what you did. If something is missing, this is low-hanging fruit almost, or not?
There's enough low hanging fruit, but there's also interesting work to do. So what I in my last blog post that I will publish like today, and that is probably also before this episode airs. But what I want to do is well in this introduce like the working with eBPF maps. So now my whole eBPF program, now your Java programs can work with eBPF maps and can communicate with your eBPF program.
Like Kafka something, right? So similar. What
not like Kafka, but it's like it's like it uses helper methods to give you like the
memory map buffer, right? Something like this.
It's not memory. It uses on it. Yes, kind of. Just read my blog post on this topic. But the cool thing with this is that you can define your structures. You can store structures in, for example, in arrays or maps in eBPF, but you currently have to define the layout of your struct in Java, and it's pretty cumbersome. But in the future, I want to do more pre-processing so that much of like the tedious work is done in preprocessors. And in the future, one of my aims is also to be able to let you skip all the C writing stuff, so you don't have to write C in a string in your Java program. So in the future, I might want to allow you to write Java code that syntactically Java code and also semantically, but that is compiled down to C code. So I don't map all the semantics of Java, but I map some of the semantics, especially like the type system, down to use it to like allow you to model C code in Java code. So this will be an interesting project that I want to work on, like using a preprocessor to essentially allow you to write C code in Java code.
Back to your Hello BPF, which replicates lib or BCC. Well, it's called libbcc or BCC.
It's called like BCC is the project and libbcc is like the library.
Yeah, and the newer one or the more professional one is libbpf, right? So it's
yes,
libbcc and libbpf is the full stack, and
yes.
libbpf is just the bytecode thing. So
Probably.
What you can do with your thing is you have a BPF builder. You can define the C code. And then with a syscall, exec VE. What is the exec VE? What is
for the people that are listening to this podcast? I think you're currently on my README for the whole eBPF program.
I'm a blog post from the 31st.
Oh yes, there's the you're on my blog post, but the README is essentially the same. So essentially, what you do, you have the BPF builder, and that allows you to like load this program compile this program using BCC, load it into your kernel, and then you can ask the libbpf for example here for syscall. So hey, please give me the ID of the syscall exec4e, and then you can tell my BPF class, please attach a method that I defined in my eBPF program to a specific syscall, and then in the simplest example, you can just tell it, hey, please trace print all the things that.
So 5 lines of code, maybe 5 lines of code,
yes.
and we are done. It looks actually. There is the underscore notation from C.
Yes,
but it looks very Javanese, I would say. It is a nice API. Even you have try with resources, so it is closed after, it seems like.
Of course, yes. I use try with resources. Python doesn't use it, but I like try with resources.
Auto closable to implement it. So it's a nice little API. for Java developers. So, are you
Yes,
aware of Project Babylon?
there's so many projects out there.
There is an OpenJDK Project Babylon, and what they're working on is called Code Model. And what they are able to do is you can compile Java to Code Model, and the Code Model is something like an abstract representation of the execution. And from there, you can compile Wasm, you can run on GPUs or whatever. So you have instead, cancel 3 conferences maybe, and the next homework assignment would be to compile, to create from Code Model bytecode for eBPF, right? So this would be interesting.
No. That's
Why not?
Because the problem is I can't model all the semantics of Java. For example, garbage collector so couldn't be modeled in eBPF because eBPF.
No,
is
but
too
there's a
restricted.
Code Model. There's also no garbage collector.
Oh, I know, but the problem is the eBPF programs are quite restricted, so they can't be too large. And
As Wasm are. So I think it will be possible.
But it's in theory it's possible, but the problem is eBPF programs should be small, and when you compile it down to Wasm, it's okay for the project Babylon to create large files because that's fine with Wasm, but it's definitely not fine with eBPF. It should be as small as possible, and I don't want to have I want just the user to be able to write the eBPF code syntactically and on a type level, model it in Java code, but not port the semantics of Java to eBPF.
No, but you could have a verifier whatever, right? So you could just use the technology to produce small things. So I would say it's not like the expectation is, to cross compile the Apache web server to eBPF. Is more like, or Tomcat. It's more like, okay, I have a small piece of code if else in Java, and now I use Code Model to create the bytecodes or this. Yeah,
I might be looking into, and I can send
look at this. It's very interesting. It's just another hint.
It could be, and I'm also looking forward to the other cool Python projects. But the annotation processes also can get us quite a long way with this. So annotation processing is cool.
Then you should take a look at Micronaut project.
There are many cool people also at the Quarkus. Also with Quarkus, they also do a lot of cool things. And
usually I mention Quarkus. Once I wanted also to mention Micronaut. So and now you're saying Quarkus. Yeah, I work with Quarkus all the time actually, but I see Micronaut is also as interesting.
I just know people from the Quarkus community. There's this Max.
Yeah, Max Anderson.
Yeah, Max Anderson. He's pretty cool. He helps me with AP Loader. He has this JBank project.
JBank, exactly. This is
you can
passionate JBank.
And that's pretty cool. And I talked a bit with other people in the Quarkus community at conferences, as you do, because they are always at the Red Hat booth. So. But I've never used Quarkus because I'm an OpenJDK developer, so I work behind the scenes on this. And that's the same what I do with Hello eBPF. I want to empower the community to write cool monitoring solutions, and that's where I see my place.
But one cool Quarkus project would be that you write an extension which installs an eBPF Quarkus extension, which installs eBPF extension, and, for instance, provides Quarkus monitoring data, right? Because this something like this, a hybrid, could be interesting. So
I thought about this. I thought about using, and that's one of the aims of the Hello eBPF programs, that people that already write their monitoring solutions in Java can easily use eBPF with this and can easily communicate. Because what you would probably usually do is you have a small monitoring solution using eBPF, like a small eBPF kernel around eBPF, because this has to run as a user, as a root user, and this can then communicate with other Java applications. For example, using sockets, using JSON to communicate then with other Java applications with your proper monitoring application that doesn't run in as a root user. And yeah, it could be definitely in the future be possible to write proper monitoring solutions in Java. And because currently when people want to use eBPF in the Java monitoring solutions, they have to go the Go route. They have to use Go or Rust, and I don't know. We in the Java community, we are cool too. We want to use all the cool monitoring tools out
Not
there.
we are cool too. We are the coolest, right? So the others try to replicate our coolness, but it's really hard to achieve. So on that
Yes.
truth, right? This is absolute. There's no argue with it. So we can argue about about eBPF and your approach, but not that Java is cool. So
Yes.
where people can find you, mostly nerdless.de. This is
Yes.
yeah.
And you can find my team at zapmachine.io. And we're a cool team. And you can find me at many conferences near
And
you.
all conferences in April, what I learned, worldwide,
No,
usually.
no. just you can find me with a deep dive in Java.
So we can say if Johannes is not at a conference, is suspicious, right? Is it a fake conference or something? Is this nothing to do with software engineering? Let's say, right?
No. I applied to a few cool conferences, but didn't get in. But at least I'm going to Javaland.
What you said right now, right? You say you applied to a few cool conferences, but you couldn't get in. So what it means about these conferences you are speaking right now, right?
No. The thing is, I'm really looking forward to all the conferences, but I of course applied to for example, to JFocus, which is pretty cool in Sweden. But yes, it's the thing when you apply to conferences, you only
They
get to
didn't appreciate the coolness of eBPF, so therefore you should ignore JFocus. If they accept, Johannes, attend JFocus. On that note, we close the podcast and see you next time, right?
Yeah, see you next time, and I hope to see you probably at the conference. Are you at Javaland by any chance?
No, no time. Javaland is too early, but I will. I try to avoid conferences, and then later, if I have no chance, then I will attend a view. But the first one is in CERN. I'm in CERN in a conference.
Oh, I didn't get in, but that's cool. I envy you to get to CERN. I'm just going to Vox Day Zurich, but looking forward to being in Zurich again. And I have a friend who lives there, so I'll be coming there to Vox Day Zurich, and then later a few days I'm going to ride my travel bike around Zurich and have a nice time after conferences. So
No, thank you.
then thank you for having me again, and thank you for the people listening here, and read my blog and go to zapmachine.io to see what
Absolutely
what cool things we do in the Java world. Yeah.
Bye.
Bye.